Today, we're popping the hood on human physiology to explore the actual, literal science of building muscle. We are moving way beyond your typical gym bro science. Instead, we're relying strictly on the latest research, including some massive comprehensive reviews and the 2026 ACSM Resistance Training Guidelines to understand exactly how your muscles adapt to strength training. But first, we've got to start with a question that challenges a huge gym myth. Does the pump actually build muscle? We all know that feeling, right? Your muscles swell up, they feel super tight, and it genuinely feels like you just did a phenomenal job. The popular logic goes kind of like this. Pump equals cell swelling, which equals fluid, which equals muscle growth. But does that temporary swollen feeling actually cause structural, long-term muscle adaptation? Hold on to that thought because the answer we find in the data might literally change how you approach your very next workout. To get there, we really need to understand what we're actually trying to achieve in the first place. Let's look at this definition word for word. Hypertrophy, the increase in muscle size occurring when existing muscle fibers grow thicker and stronger through cellular repair. Now, it's absolutely crucial to note that this is not about creating new muscle fibers. That process is called hyperplasia, and it's virtually non-existent in humans. Instead, your body focuses entirely on enlarging the fibers you already possess. You're essentially taking an existing rope and adding more threads to make it thicker and stronger. Here is our blueprint for today. Chapter 1, Anatomy of Growth. Chapter 2, The Primary Driver. Chapter 3, The Repair Crew. Chapter 4, Stress and Hormones. And Chapter 5, Actionable Strategies.
Chapter 1, The Anatomy of Muscle Growth.
Now, what's really interesting about this slide is how clearly it contrasts the two very different ways a muscle compartment can expand. First, we have myofibrillar hypertrophy. Think of the myofibrils as the engine. This is the dense contractile machinery, the actual parts producing the physical force. Second, we have the sarcoplasm. Think of this as the factory floor, the gel-like internal environment surrounding that engine. It holds the fluid, glycogen stores, enzymes, and the mitochondria that support the fiber's function. Sarcoplasmic hypertrophy is essentially a disproportionate expansion of this factory floor relative to the engine. Knowing the difference between the actual engine and the fluid that supports it is totally key to understanding what truly drives functional muscle growth.
Chapter 2, The Primary Driver, Tension.
So what actually forces that engine to adapt and grow? The most current comprehensive reviews are absolutely direct about this. They state, mechanical tension is the essential primary driver of load-induced skeletal muscle hypertrophy. That is a definitive scientific statement. What it means is that without hard contractions under a heavy load, nothing else really matters all that much. If the muscle isn't exposed to enough high-tension work, things like the pump or metabolic stress simply cannot get the job done on their own. Tension is for sure the undisputed boss of muscle growth.
So, how does this tension actually do its magic? Well, when you perform high-tension work, like grinding out a heavy, challenging lift, it forces your nervous system to recruit way more motor units, specifically your larger, fast-twitch muscle fibers. This intense mechanical stress physically disturbs the integrity of the skeletal muscle. It actually causes microscopic damage, or micro tears, in the fibers. Now, tearing sounds bad, I know, but it's actually the essential distress signal your body needs. These micro tears are exactly what trigger your body's internal repair systems to kick into high gear and build the muscle back stronger than it was before.
Chapter 3, The Repair Crew, Satellite Cells. Sitting quietly between each muscle fiber and its outer membrane are these incredible muscle stem cells called satellite cells. When damage happens from high tension, they jump into a 3-step process. Let's go through this word to word. Step 1, activate. Biochemical signals wake them from their dormant state. Step 2, proliferate. They rapidly divide to expand the local stem cell pool. Step 3, differentiate or fuse. They physically fuse with the existing muscle fibers, donating their nuclei to patch the injured area. And this brilliantly illustrates how these cells literally donate materials to rebuild stronger fibers. It is the absolute foundation of muscle recovery and growth. Now, you might be wondering about the aging process here, because as we get older, satellite cell quantity and efficiency do naturally decline, which contributes to muscle loss, or sarcopenia. But here is the truly incredible news from the research. Consistent resistance training actually re-stimulates the satellite cell activity. It improves their regenerative power, meaning you can partially reverse this downward trend. Age is just a hurdle, you guys. It's not a brick wall. Lifting weights keeps this cellular repair crew active and robust right on through your 40s, 50s, and way beyond. Chapter 4, Metabolic Stress and Hormones. Let's move to and see how this builds, visually, into an understanding of metabolic stress. Metabolic stress is basically the buildup of byproducts like lactate when you're relying on anaerobic glycolysis during moderate rep training. The mechanisms at play here include increased fiber recruitment, elevated hormonal release, altered myokines, the production of reactive oxygen species, and cellular swelling. That cellular swelling, that is exactly what bodybuilders call the pump. Now, while tension is the primary driver, this resulting metabolic stress and fluid accumulation acts as a fantastic secondary signal. It completely optimizes the environment for protein synthesis and satellite cell fusion. And right alongside that metabolic stress, we have an acute hormonal response. Resistance exercise, specifically protocols that are moderate to high intensity with short rest intervals, triggers a significant spike in some massive key anabolic hormones: testosterone, growth hormone, insulin like growth factor 1, and insulin. These hormones spike during your workout and stay elevated for about 15 to 30 minutes post-exercise. But it's super important to understand what these hormones are actually doing. Current research indicates that these acute, temporary spikes don't necessarily drive the growth all on their own. Remember, mechanical tension is the boss there. Instead, these hormones act to kickstart local tissue repair. For example, local forms of IGF-1 activate satellite cells, while systemic IGF-1 helps them fuse to the fibers. Basically, this neuroendocrine response creates the ultimate permissive environment, ensuring your repair crew has every single thing it needs to synthesize new protein efficiently. Chapter 5: Actionable Training Strategies. All right, let's translate all this dense cellular physiology into a highly actionable blueprint you can take straight to the gym. Based on the literature and the 2026 ACSM guidelines, here are your 6 non-negotiable growth levers in order of priority. Number 1, mechanical tension. Hard contractions under load are required. Number 2, sufficient volume. You need enough hard sets. Number 3, progressive overload. Over time, you've got to increase the weight or reps to keep challenging the muscle. Number 4, proximity to failure. The sets have to be hard enough to recruit those fast twitch fibers. Number 5, specificity. You get better at exactly what you practice. And number 6, recovery and nutrition. Remember, training is just the signal. Recovery is where the adaptation actually happens. Let's quickly zero in on lever number 2, volume. 10. This specific number is the scientifically backed starting point from the 2026 ACSM guidelines, which synthesized over 137 systematic reviews. 10 hard sets per muscle group per week is the absolute key volume lever for hypertrophy. Hitting this number ensures you're creating enough of those micro tears to force structural adaptation without completely frying your nervous system and overwhelming your ability to recover. And regarding lever number 4, proximity to failure, the research reveals a really critical nuance. You do not need to train to absolute momentary failure on every single set to grow muscle. In fact, for heavy compound lifts, stopping 1 to 3 reps short of failure, leaving just a little bit in the tank, is highly effective. It protects your form, manages your systemic fatigue, and it still provides the high-tension environment required to recruit those big motor units. Now, for smaller isolation exercises, sure, you can push a bit closer to failure, but you absolutely don't need to completely destroy the muscle to grow it. So the crucial point is this: when you step into the gym today, are you just chasing the pump, or are you chasing tension? The pump is awesome feedback that you're hitting the target muscle, and it brings that metabolic stress that aids the repair environment. But the pump doesn't cause the structural growth. Mechanical tension is the engine. Hard contractions, progressive overload, and consistent recovery are what wake up your satellite cells to build actual structural muscle. Take these 6 levers, apply them to your very next workout, and start building the engine, not just the factory floor.
Thanks for watching. Subscribe our channel, which give us motivation to make better content for you. See you in the next video.